Hi guys, this is Mrs. Jacqua. It's Core 4, April 15th. It's week 5, 4? It's week 4. Okay. So we're gonna be working on vectors and then we'll later work on polar coordinates, complex numbers. That's for this unit. Okay, 2 out of 3 people have trouble with fractions. Haha, that's funny. Pause and laugh. Okay, so today what we're gonna do is we're gonna be talking about vectors. Vectors, not vector, get it? Anyway, but in the movie, he even states, like in Despicable Me 2, he says he gave his name Vector because it has direction and magnitude. So let's just real quick look through which one is which. Vectors have magnitude and direction. A scalar will either have a size or a magnitude. Now, just so you know, magnitude is super similar to direction. So it's one or the other, but it's not. It's size or magnitude, but it's not both. So let's connect our dots. I'm gonna make my screen bigger because I can. Nobody's here. So a car traveling 60 miles per hour at 15 degrees east of south. That would imply magnitude and direction. So A belongs to vectors. Okay, so a parachute falling straight down, it's telling you how they're falling at 25 miles per hour. So B would also be a vector. And then a child pulling a sled, and it's just saying pulling at a force of 20 newtons. So that would just be our scalar. Now, if we said that they're pulling at, I don't know, south, east, west, giving a direction, then it would become our vector. Okay, so vectors are kind of fun to draw. And recognizing how to say something is kind of cool too. So pause and look at this thing. And what I'm going to do is I'm going to scale that so that's 10 and then 20 and then 30. The way that we draw this is if we're looking at 2A, I'm looking at 20 feet. So 20 feet means that I'm in this circle range, 20 feet away from the origin. Okay, and then when it says that I am bearing of 065, what that means is I start from north and then I go 65 degrees from north. Okay, and so that's how I get there, but my vector is going to be in blue. There's my initial side. There's my terminal side, and we're going to put a big old point there. Point there, and an arrow belongs on it. Hopefully you can see that arrow. So not the red. So let's take off this red sucker and delete it, make it go away. Okay, so it's the blue vector. That's how you do that one. So what do you think about 15 miles? So we're going to once again consider our scale 1 equals 10. So if we're doing 15, then we're in the middle of 2. And I'm going to go ahead and draw my circle. That's 15 out. And then let's talk about bearing south, east 20. So I headed south, and then I'm going to go to the east, 25 degrees. So that's 25. And I'm going to create my vector in red. So here's my initial point, here's my terminal point, and my vector goes to it. And we have an end point, and we're pointing to initial is the starting, and where it points to is the end point for vectors. So now let's look at 60 pounds of force. So 10 will equal 20. Or 1, hold on back. 1 will equal 20. So if we go out 60, that's this circle here. It's that circle, and then that's 80 degrees from horizontal, so that means it's up here. That's 80 degrees. And let's do a green vector. There's our initial, there's our terminal, and then we're going to do a vector to the green. Cool. It is cool, by the way. So push pause and read through this. Since you're not here, I don't have to wait for you to do that. But those are just different ways of showing how to get to. I need to identify something. This is our endpoint. And they're both ways to get to the same endpoint. You can follow A, go to B, then you'll end up at A plus B. So if we look at these, A minus C plus 2B. What that means is we're going to take A, so let's start it. We're going to pretend there's an origin there. And we're going to do minus C, so we're actually going to go down, not up. And let's see if this will copy and paste. Nope, it won't. So what I need to do is I need to make that twice as long. So, because oh, just kidding. I'm not making it twice as long. It's A minus C. So same size. You got to follow the directions. Now we need to have our arrows. Our arrows are really important on these. And then it's going to be minus 2B. So what we want to do is we want to have B twice the length of B. So then we're going to go plus 2B, so we're heading back up. And that's our lovely endpoint. So the resultant vector actually would be, here's my initial, there's my terminal. This black one would be the resultant vector. Kind of cool. I think it's fun. I just like drawing this stuff. So if we were to do M, we're going to start out with M. So we're going to start in our initial point. We'll draw a little arrow. And then we're going to minus P. So that means we're going to go that direction. We're going to head down. But it says that we want P to be 1/4. So that's about 1/2, and that's about 1/4. So then I'm going to move it here and put a little arrow and put a big old dot. And then my resultant vector, I'll put in green, initial to terminal. Anyway, that's my resultant vector. Practice this stuff, guys. It comes kind of easy-ish. Okay, so we're going to draw a diagram. A player kicks a soccer ball so that it leaves the ground with a velocity of 44 feet per second at 33 degrees angle. So we're going to draw a vector with this. So everything's ratio. So when we deal with ratios, we deal with trig. So we need to know our SOHCAHTOA. So if we want to know the blue vector, we are using sine, and this is opposite. So this is the y vector. It will equal the sine of 33 degrees equals opposite, so the y guy, over your hypotenuse. So use a super cool calculator, and oh, where did mine go? Use a super cool calculator to find it out. So y vector is going to be 44 times sine 33. Whoops. Make sure your calculator's in degrees. Changes your answers. 44 times sine 33. Okay, so the y magnitude or vector is 24. Probably feet per second. Let's look at the red magnitude, which is the x one. Undo that because that turned out to be a y. So the y x magnitude. It's going to be cosine 33 degrees equals the x dude over 44. So if we take 44 times cosine 33 equals And this one is about 36.9 feet per second. Okay, so I drew my diagram. I forgot to totally read stuff. You should have paused and read it yourself. There's my diagram. And then the horizontal is the x dude, and vertical is the y component of the velocity, 24 feet per second, and the other one. Cool. Okay, so this stuff is kind of easy-ish. Pause and read the notes because I'm gonna just process through it. So this is what I'm doing. 6 minus a negative 2, because I'm taking my y guys, comma, now, or my x guys, now I'm going to take my y guys, 1 minus a negative 7. So the resultant vector is 8, comma, 8. Okay, let's go to the next problem. Same idea, this is the formula that I'm using. I already did that one, so I'm going to take my x's. So I get negative 9, I take the second one first. Whoopsie. Minus 0, comma, negative 3 minus 8. It's my resultant vector. Okay, and I can draw and graph those and plot them. They're kind of cool. I like doing that stuff. Okay, so on this one, you should push pause and read through it. But all I'm going to do, so the magnitude, we're talking about the magnitude. It's a distance idea. You've seen this formula before in Pythagorean's theorem when we're trying to find the distance between 2 points. And that's all we're going to do. So we're going to work on this problem first. So we're going to do the magnitude of A, B equals the square root, parentheses, negative 2 minus 6 squared. Oh, let's do it the way they have it, so you guys don't ask me where I get my numbers from. 6 minus a negative 2 squared plus 1 minus a negative 7 squared. So absolute value AB equals square root 64 plus 64 equals square root 128 equals 8 square root 2, which is approximately, I don't know, which is approximately 11.31. Cool, we already did that one, so let's just work the other one. B, so magnitude of this AB, because they're different, right, equals square root negative 9 minus 0 whole thing squared plus negative 3 minus 8 whole thing squared equals square root 81 plus 121 equals square root 202. And calculator is approximately 14.21. Okay, that's how you work those problems. They're not very hard. They're kind of fun. Okay, so we're not working those two. We'll get to those in a second. What I'm going to do is I'm going to focus on this. These are called scalars, and then we're adding them and we're combining them. So with 4W, let's focus on that. With 4W equals vector negative 16, comma 4. Just multiply everything to each other. Okay, and then Z equals negative 3, comma 0. And when we combine those, we get a resultant vector of this, which is negative 19, comma 4. Just add them together. That's it. Let's practice another one. We're working on negative 3W. So let's multiply this by negative 3. So it's going to be 12, comma negative 3. That's it. Oh, let's work on another one. Not that one. I'll work on this one. So we have 2W equals 4y equals, and then negative z. Let's do those parts. If I have 2w, that's negative 8, comma 2. If I have 4y, that is 8, comma 20. If I have negative z, that is positive 3, comma 0. And final answer, we'll do olive color. It's an olive color. Just add them all up. So negative 8, 8, 3 is 3. 22 and 0 is 22. It's my resultant vector. Kind of cool. I like this stuff, by the way. It's fun. This one's kind of the hardest. Oh, there's other harder ones, but it's the hardest one I'm doing in a webinar. Just do that. Remember that this equals the square root change in x squared plus change in y squared. That x didn't turn out very good. So we're going to ignore that one. So let's look how to do this one. If we want to do the unit vector equals w divided by the magnitude of w. So let's find the magnitude of w. Square root 6 squared plus negative 2 squared equals 36 equals square root 40, which is 4 square root 10. Not 4, it's 2. It's 4 times 10. 2 square root 10. So this, whoops, let's do another line in different color. So this equals 6 comma negative 2 divided by 2 square root 10, which equals 6 over 2 square root 10 comma negative 2 over 2 square root 10. Rationalize the denominator and simplify, and I'm going to do that simultaneously. So I get 3 square root 10 over 10 comma negative square root 10 over 10. Because the 2 schnicked, 6 went to 3, and then you want to multiply top and bottom by square root 10 over 10. So that bottom one is my resultant vector. Super cool. Ready? New one. So first find the magnitude of x. That equals square root negative 4 squared plus negative 8 squared equals square root 16 plus 64, which is 80, which is 16 times 5. Square root of 16 is 4, square root 5. So when I look for my unit vector, it equals x over the magnitude of x, which equals negative 4 comma negative 8 all over 4 square root 5, 4 square root 5 equals negative square root 5 over 5 and negative 2 square root 5 over 5. Cool. All right, guys. Since nobody was here, the webinar was super short. Have a good day.